All right, this is 6th grade, Unit 3, Lesson 5. And in this lesson, students are going to be learning about the unit rate, and they're going to be using the unit rate as a really powerful and useful way for comparing different rates. So we're going to be specifically thinking about speeds and prices mostly in this lesson. So let's get started. And we're going to begin with a warm-up, quick 5-minute warm-up. Is the value of each expression closer to a half, closer to 1, or closer to 1.5? And so we're going to be thinking about 20 divided by 18, but I'm going to think of this as 20 over 18, so 20/18. And I can kind of get a sense that, okay, well, that's 20/18. That's pretty close to something I could do in my head. And that's 1 2/18, which means it's probably closer to 1. I can think of 9 divided by 20 as 9/20. And I know that 9/20 is really close to 10/20, which is half. So I know that 9/20 is probably closer to a half. And then 7 divided by 5. Well, I'm going to think of it again as a fraction. 7 divided by 5 is 1 2/5. And that's pretty darn close. That 2/5 is pretty close to a half. So I'm going to say that's really close to 1.5. So there's our 5-minute warm-up. Now we're going to go on to treadmills. So we've got some students. They did a treadmill workout. Each one is running at a constant speed. Answer the questions about their workouts, explaining or showing your reasoning. So we've got Tyler. He ran 4,200 meters in 30 minutes. Kieran ran 6,300 meters in a half hour. And then Mai ran 6.3 kilometers in 45 minutes. So first off, teachers, what we want is for students to be thinking about what is the same in this case between Tyler and Kieran? Well, we can see that they both ran meters. And then what is the same about Kieran and Mai? So we can see that Kieran, let's see, Kieran and Mai. So Kieran ran in meters, but Mai ran in kilometers. But what's the same? Well, that's the same distance. 6,300 meters is the same as 6.3 kilometers. So that's what's the same. And then what's the same about Mai and Tyler? Well, Mai and Tyler both ran in minutes. So they both ran in minutes. And that's what's the same, I guess. I mean, there could be other things, but there you go. And then let's see, at what rate did each of them run? So we want to find like some unit rate. So let's start by making some tables. So I'm going to make a table for Tyler. And Tyler is going to look like this. Let's see, Tyler. And we're going to do meters and minutes. So that doesn't help much. So let's do there, min. Okay, meters and min. And so he did 4,200 in 30 minutes. Yep, there we go. So if we want to know, like in 1 minute, how far did Tyler run? Well, what we could do is we can scale both of these by 10, divide both of them by 10, and that's going to give us 420 in 3 minutes. And then we can scale it again, scale down, and let's by 3. So we could divide both of these by 3. And then now we know that Tyler in 1 minute, because that's the 3 divided by 3 right here. And then we have to do 420 divided by 3. And 420 divided by 3 is 140. So in 1 minute, Tyler can go 140 meters. I'm not entirely sure if that's fast or slow. To be honest, I don't know. So now let's do the same thing, but now we're going to do Kieran. And so right here, meters and minutes for Kieran. And Kieran did 6,300 meters. Now it says in a half hour. So what that means is I'm going to change that to 30 minutes. And again, let's go and scale this down till we get a unit rate. So I'm going to begin by dividing by 10 because I see both numbers end in 0. So that automatically tells me I could divide them both by 10. And so that gives me 630 and 3. Oh, that tells me a lot, doesn't it? So I see that I can divide again. I can scale them down by dividing by 3. And we get 210 in 1 minute. Now, don't forget, all of these ratios are equivalent. They're all equivalent. We're just scaling them to use smaller numbers, but it's describing the exact same speed, the exact same rate that Kieran is running at. And heck, we knew who was faster right from the very first line, didn't we? Because, what is it? Tyler in 30 minutes ran 4,200, while Kieran, same amount of minutes, 30 minutes, ran 6,300 meters. And then we have one last person. We've got Mai, and let's get Mai in there. And Mai, I'm going to do an M for Mai, meters and minutes. Now remember, Mai did 6.3 kilometers, which is 6,300 meters. And she ran in 45 minutes. So let's zoom in and find the unit rate for that. Well, we can't scale down by 10 easily because they don't both end in 0. But another number that's going to be useful is 5, dividing by 5. Scaling both by 5 gives me 1, 2, 2. Gee whiz, what is it? 1, 2, 2, 0. There we go. That doesn't, yeah, that's right. And then, and then over here, 45 divided by 5, that's a quickie, that's 9. Okay. And then, let's see, 1, 2, 3, 4, 5. I don't feel that's right. Let's do 6,300 divided by 5. There's my 1, there's my 3. Oh, there it is. So 2, that's 10, and there's my 3. So now when I bring down the 0, that's going to be a 6, 0. That's right. So that makes sense. So that's going to be 1, 2, 6, 0. So 1,260. I was trying to do it in my head. It just didn't feel right. But now we know, using our divisibility rules, that since 1 plus 2 plus 6 equals 9, that tells me it's divisible by 9. All right, so I know both of these numbers are divisible by 9, and that gives us our new unit rate. 9 divided by 9 is 1, and then 1,260 divided by 9 is going to be 9, 10, 11, 12. So that's going to be 140. So in 1 minute, Mai can run 140 meters. All right. And so there's our 3 unit rates. And down here, at which rate, or at what rate did each of them run? Well, that's our answers over here. So we've got these answers, and I'm just going to copy them, and I'm going to paste them down here so that we could see them again. And then it says, how far did Mai run in her first 30 minutes on the treadmill? Right there. How far did she run in 30 minutes? Well, what are we going to do? If we want to know how far Mai runs in 30 minutes, then what we're going to do is we're going to take her unit rate and scale up by multiplying by 30. So if she my minutes. If she does 140 meters in 1 minute, then I'm going to scale up by timesing by 30. Because this says in 1 minute she can travel this far. So if we multiply by 30, and then we're going to do 140 divided by 30. And I know, let's see, 3 times 4 is 2. Carry the 1. 4, and then stick on 2 zeros. So in 30 minutes, she can run 4,200 meters, which happens to be exactly what Tyler did in his time. And then our third example, our third activity is another 15 minutes. 4 different stores posted ads about special sales on 15 ounces cans of baked beans. Which store is offering the best deal? And we just need to explain our reasoning. All right, so what we could do is we could find the price for 1 can. All right, and that's one way to do it. And let's do it. So let's do the first one. We're going to call this, let's call this A, B, C, and D. All right. And so A is 8 cans for $6. All right. So A, let's see, cans and dollars. So we've got 8 cans is $6. So if I want to know how much is 1 can, so I want to know 1 can, so I'm going to scale down by dividing by 8, because 8 divided by 8 gives me 1 can. 6 divided by 8 is 6 divided by 8 like that, 6/8, which happens to be 3/4, which happens to be 75 cents. So 1 can costs 75 cents for option A. Now let's do option B. Option B is 10 cans for $10. Well, that's pretty darn easy. Option B, cans and dollars. 10 cans for $10. That's pretty easy. That's 1 can for $1. Option C, 2 cans for $3. Option C, 2 cans for $3. Now here we want a unit rate. So I want to know 1 can. What is 1 can going to cost? So we're going to divide by 2. 2 cans equaling $3. So we cut it in half. That gives us 1 can. So 3 divided by 2 is 3 halves, which is 1.5. So 1.5 for 1 can. So $1, 1 can costs $1.50. 1.5 is $1.50. $1.50. And then that option D is easy. 1 can is 80 cents. So that's option D. We don't even have to do any math there. So now we can automatically see which one's the best deal. The best deal is option A at 75 cents per can. The last store listed, so I guess it's, what is it, option D, maybe? I don't know. Is also selling 28-ounce cans of baked beans for $1.40 each. How does that price compare to the other prices? So now we've got this 28 ounces for $1.40. Now all of these, how many ounces were they? They were 15 ounces. All right, so I want to know, how does that compare to the other prices? Well, why don't we scale? Let's scale it down to 15 ounces to see how much it costs for 15 ounces. So what we're going to do is we're going to make our table. But this time we have ounces and dollars. And we're going to start with 28 ounces as $1.40. But I want to scale that down to 15 ounces in some way. How am I going to scale it down? Well, I could start by, let's see, dividing by, well, if I divide by 7, because I kind of see that $1.40 sort of looks like a 14. And I know that 28 and 14 are both divisible by 7. So let's do that. So 28 divided by 7 is 4. And $1.40 divided by 7 is going to be 20 cents. I could scale down again. This time I'm going to scale down dividing by 4 because I want to get that unit rate. Dividing by 4. So now I get 1 ounce is equal to 0.05 pennies. So that's 5 pennies. 5 cents is what that is. So 1 ounce costs 5 cents. So if I want to scale it up to get to 15, remember I was trying to get to 15, I'm going to multiply by 5. Multiply by 5. So that gives me 15 ounces right here is equal to, and in this case, it's 0.75. So it turns out that this right here is the same rate as option A up here. There it is, option A. There's our summary. And now we're going to do a quick whip through for our practice problems. Mai and Priya were on scooters. Mai traveled 15 meters in 6 seconds. Priya traveled 22 meters in 10 seconds. Who's moving faster? All right, so let's do Mai, 15 and 6. So Mai, 15 and 6. So that's 15 meters in 6 seconds. And that's Mai. And then we've got Priya is 22 in 10. So Priya is 22 in 10. So 22 meters in 10 seconds. And we want to know who is traveling faster. Well, it might be easier if we somehow get our seconds to be the same. All right. So I think what I'm going to do, I'm going to kind of, if I multiply and scale up by 5, I get 75 meters in 30 seconds. That's for Mai. And then for Priya, I could do something similar. I could scale up by 3, multiplying by 3. That gives me 66 meters in 30 seconds. So I now can see that Mai is moving much faster than Priya because in 30 seconds, Mai can travel 75 meters while Priya only travels 66. Right, here are the prices for cans of juice that are in the same brand, same size at different stores. Which store is offering the best deal? Explain your reasoning. And so what I'm going to do is I'm going to make a bunch of tables and find a bunch of unit rates. So let's get here. And we've got 4 cans for $2.48. So we've got cans and dollars right here. And I'm going to scale down to 1 can. So how do I scale down? I'm going to divide by 4, which means I'm going to divide by 4, and that gives me 0.62. So 1 can costs 0.62. So that's 62 cents. And let's take a look at this one. And so this one is going to be 5 cans for $3. So cans and dollars. And I want to know 1 can. What is 1 can going to cost? So how do I do that? I'm going to divide by 5. 3 divided by 5 is 3/5, which happens to equal 0.60. So that's 60 cents. All right, here. So far, store Y is winning. And then let's take a look at store Z. Store Z, so that's 59 cents per can. Oh, I don't have to do anything. That's already a unit rate, isn't it? And I can see that store Z wins just barely by 1 penny. It just barely beats out store Y. All right, question 3. The costs of homes can be very different in different parts of the United States. We've got a 450 square foot apartment costing $450,000. That's a lot of money. What is the price per square foot? So I want to know how much money does it cost for 1 square foot? And then we've got a 2,100 square foot costing $110 per square foot. How much does this home cost? Okay, so let's start with A. We've got a table, and we're going to put 450 right here, and we're going to put 540,000 right here. So this is square feet, SF, and then this is money right here. And I want to know, what is the price per square foot? Meaning I want to scale down to 1 square foot. And so if I'm going to scale down to 1 square foot, I'm going to need my calculator on this one, I think. So that means I'm going to divide by 450, which means I'm going to scale down by dividing by 450. And so 540,000 divided by 450. So I'm going to divide by 450. That gives me $1,200 per square foot. That's crazy. That's expensive. Okay, so anyway, question B, we've got a 2,100 square home costing $110 per square foot. How much does this home cost? So that's going to be 2,100 multiplied by 110. And when I do that, I'm just going to get my handy dandy calculator, multiply 2,100 times 110. That gives me 231,000. All right. And that's how much that house would cost. Beautiful. All right. Question 4. There's 33.8 fluid ounces in a liter. There's 128 fluid ounces in a gallon. How many liters are in a gallon? My goodness. Okay, so let's see. There are 33.8 fluid ounces in a liter, and there are 128 fluid ounces in a gallon. And so I want to know how many, like right here, here's 128. I want to know if this is a 33.8, that equals 1 liter, 1 L-I-T-E-R, 1 liter. And then here's another 33.8 fluid ounces. So that's another liter. And here's another 33.8 and another 33.8. And so what am I doing? I'm figuring out how many 33.8s are in 128. So basically what I'm doing is I'm doing division, aren't I? I am dividing 128 by 33.8. So I'm doing 128 divided by 33.8. So I'm going to use my calculator and I'm going to type in 128. There's my 128 divided by, and then I'm going to type in 33.8, and I got 33.78. 3.79 because it rounds up, right? 3.79. So the answer is 4, but we kind of knew that. How did we know that? All we needed to do is we needed to think about addition. 33 plus another 33 is 66, plus another 33 is 99, plus another 33. 99 plus 33, that's easy. That's 100 plus 33, but really you move one over. So it's really 100 plus 32, which is 132. And that's pretty darn close to 128. So we knew without any calculation, without any calculator, we knew that the answer was about 4. All right. And then Diego is 165 centimeters tall. Andre is 1.7 meters tall. Who's taller, Diego or Andre? Well, we know that there's 100 centimeters in each meter. So Andre is 170 meters. Diego is 170 centimeters. Diego is 65 centimeters. So Andre is taller by 5 centimeters. Name an object that could be about the same length. So identify things that are about each of these lengths. I'm going to just let you play with that, parents and teachers, because this is pretty straightforward. And that wraps up. My goodness, that was a quickie. Not really. That wraps up grade 6, unit 3, lesson 5, comparing speeds. And you know what, folks? Don't forget to subscribe.